In this video, we continue talking about correlation. We talk about some common facts that are about correlation that are very important. The first fact is that correlation does not distinguish between X and Y. There will be statistics that we do that do distinguish between X and Y, but this one doesn't. So another way to say that is there's no implication of causality. A lot of times what we do in statistics is we try to say, does X cause Y or does Y cause X? And this measure does not imply in either. So, for example, we have the famous example of ice cream and murder rates. Ice cream and murder rates are correlated, but we don't know if ice cream causes murder or murder causes ice cream or the reverse. The second thing about correlation is units don't matter. So, for example, if we were looking about how happy someone was and how much money they made, then it wouldn't matter if we measured how much money they made on how much money they made per month or how much money they made per year, or whether we measured money in terms of dollars or in cents or in tens of thousands of dollars or in pesos. It wouldn't matter. So units don't matter. The third thing that's related to this is R itself has no unit. So R is between -1 and 1, and it has no units. The fourth thing is one that we've already mentioned, is X and Y are both variables, let's say, because we don't know which is X and Y. Both variables must be quantitative. Now, in the cases when they're not both quantitative, there are similar statistics, but R itself cannot be used. So it doesn't distinguish between input and output, X and Y. Units don't matter. R has no unit itself, and both variables must be quantitative. The fifth one is that R measures only a linear relationship. And that's important enough to draw a picture. So let's draw a picture with that one. So let's say we have X and Y here, and let's say these are our points. Right? Well, very clearly there's a relationship here, right? Very clearly it appears that there's some type of relationship that looks like this. But that's a nonlinear relationship. So if you just look at R, that is, whether or not there's a linear relationship here, there appears to be no linear relationship at all. So you would probably get an R of approximately 0 here, even though there's clearly a relationship. That's because R only measures a linear relationship. The sixth fact about R is strongly affected by outliers. What we mean by that is if you had a lot of data, but one particular individual or one particular observation was very different than the others, then that could really affect your measure of R. So you have to be very careful with outliers. And the seventh thing is really just a warning, I guess, and that is R is not enough. So when you're studying the relationship between two variables, you want to calculate R, but you also want to calculate things such as the mean between the mean of the two variables, the standard deviation, lots of other statistics, the distribution, on and on and on. So the important thing to remember is R is not enough. So let's go over these really quickly. The first four, and you can pause this if you need to write any of these down, and 5, 6, and 7. And that's part 3 of our videos on correlation.